For this video, I'm going to spend a little bit of time talking about the more advanced concepts when it comes to motion mapping. So thus far, we have learned how to construct a motion map for an object going at a constant velocity. And I'll just make a video of a motion of some object that is traveling at a constant velocity. And of course, this object that I'm drawing this for is traveling along at 2 meters per second. And so the object, you can see, travels 2 meters per every second. And the velocity vectors, I can show equalities there, showing that it's traveled the same distance per unit time. And so we'll call this constant v. Constant velocity, and in this case it's constant positive velocity. Well, what we really want to do is to be able to use this same process for objects that are speeding up and slowing down. So let's just make a simple case here. So this will be the red dots, red motion. So you can see at t0 it's still at the 0 meter mark, and at 1 second it's at the 2 meter mark. At 2 seconds it's at the 5 meter mark, so there's 3 meters in between. And then in the next second it travels 4 meters, 1, 2, 3, 4 meters. In the next second it travels 5 meters, 1, 2, 3, 4, 5 meters. Next second it travels 6 meters, 1, 2, 3, 4, 5, 6 meters. Fantastic. So let's include the velocity vectors now. And of course, just by looking at this, you can see that this object is speeding up. And so the velocity vector shows between 0 and 1 second, the average velocity is 2 meters per second. Between 1 and 2 seconds, the average velocity is 3 meters per second, and the velocity continues to rise as time goes on. And so we can look and we can say, okay, my velocity vectors show an increasing velocity. Well, I can also now include an acceleration vector into this motion map. And so I'm just going to make my acceleration vectors be a consistent color, and we'll just make that bright blue. And so my acceleration vectors look like this. So I can't really tell what's going on between 0 and 1 second, but I know between 1 and 2 as compared to 0 and 1, I've increased by 1 meters per second. And here I've increased again by 1 meters per second, and I've increased again by 1 meters per second, and I've increased again by 1 meters per second. So these vectors, these acceleration, if you will, vectors, are all equal to each other, showing that this object is speeding up at a constant rate. Fantastic. Well, let's just think about that from another perspective. And of course, this object number 2, which is accelerating, it's accelerating in the positive direction. All right, so now let's do another one of these, and this will allow you to see the complexities of this type of system. So here, let's take this object, and sure enough, it starts out at the 0 meter mark, just like the object before. Except this time it travels, in the first second, it travels to the 8 meter mark. So it's gone, the velocity, the velocity is, the average velocity between 0 and 1 second is 8 meters per second. Great. And then in the second, instead of going 8 meters, it only goes 7 meters. And so I end up here. In the third second, it only goes 6 meters. And the next second, it only goes 5 meters. So, oops, did I get that right? I think so. So I'm showing now an object that is no longer speeding up, but instead it's going from 8 meters per second for its average velocity to 7 meters per second to 6 meters per second. And, oh, I see, there's my mistake. So let's just fix this while I can. So I'm at the 15 meter mark, and I've now need to go 6 meters, so I need to go to the 21 meter mark, and then I need to go 5, so that'll take me to the 26 meter mark. Very nice. Now I've got my act together here. Okay, so the velocity decreases by 1 meter per second each time. So we go from 8 meters per second to 7 meters per second to 6 meters per second to 5 meters per second, and we could just continue on. Well, so what does the acceleration vectors look like in this case? It turns out that what is happening is we have a slowing. And so when something is moving in the positive direction, as is this object, it's moving from left to right, and it's slowing, the acceleration is in the negative direction. You might like to think of this as deceleration. However, if you do use the word deceleration, it doesn't always, that tends to mean slowing, but in this case, it might not be. In some cases, it might be that you can slow in the positive direction, so it isn't the best word for us. And so we would still consider this accelerating, but it's accelerating in the negative direction. So here we've got something traveling in the positive direction, accelerating in the negative direction. Fantastic.